Hello everyone, I am going to explain our COA topic, factorial of a small number. Code origin, sets the origin of the program in the memory location 000H, and this is where the program execution begins. And move A loads 1 into the accumulator A, and this initialization A is equals to 1, which holds the running product, and move R0 at 85H memory address, and move A. R0 is loaded with the memory address at 85, the address where the input number is stored, and move A at R0 loads the number stored at the address into A, and move R1 to A copies the value of A into the R1. R1 now acts as the counter of the factorial loop. And move back, move B, R1, multiply A and B, djnz R1 back, move B for R1, the copies the current value of an R1 into register B. It multiplies the A into B, and the result is stored as a low bit in A, high bit in A in B. For the small number is 5, overflow won't occurs, so B is equals to 0. And next decrements R1 by 1. If R1 is not equals to 0, then jump back to the label back and repeats it continuously multiplying until the R1 becomes the 0, and moves the result to the memory location 86H, so the factorial is stored at the 86 memory address. Here S jump here infinite loop, and this keeps the program running. And implementation, the implementation is the input number is stored in the memory location 85, and the program loads this number into the accumulator using the instruction LDA memory address of 85, and the value in A is then copied to the register B. This acts as a counter, and the accumulator is initialized to 1 since the factorial starts with the 1, and the program enters a loop where A is multiplied by the current value of B, and after each multiplication decrease B reduces the counters by 1. The JNZ instructs the checks if B is not equals to 0. If not 0, the loop repeats. When B is equals to 0, the loop ends, and the final result is stored in a memory location of 86. And next, sequential diagram. The sequential diagram and memory registration flow. Input number memory 85 loads the accumulator at memory address of 85, copy to the register B, move B, A, and initialize the accumulator, and loops and multiplying A and B, and decrementing and repeating the process stores the observation memory. And uses of an accumulator. The accumulator holds and updates the intermediate result after each multiplication. It acts as the main arithmetic register for the factorial calculation. All additions during the multiplications are performed using the accumulator. Finally, the accumulators accumulator contains the factorial value which is stored in the memory location of 86.